CHEM1041 and 1121. Determination of an equilibrium constant. Calculations. First off, I need to make sure that you're aware that this CHEM21 online report is rather temperamental regarding the number of significant figures you need to use and where and when. So please pay attention to the number of significant figures that I tell you to use at any given point in the report. For part 1, record and enter the absorbances you measured in lab with 3 significant figures. And that's what you would have had anyway, 3 digits to the right of the decimal point. You'll need to calculate the concentration of the iron 3 containing solution that you mixed accordingly using the dilution formula. That basically the volume of the stock solution times the molarity of the stock solution equals the volume of the mixed solution times the molarity of the mixed solution. The mixed solution is what you prepared. The molarity of the mixed solution would then be the volume of the stock solution times the molarity of the stock solution from the side shelf divided by the total volume of the solution that you prepared in the flask. Express your calculated concentrations with 2 significant figures and use scientific notation like the example I just gave you. Use the same formula to calculate the thiocyanate concentrations to 2 significant figures as well for flasks 2 through 5. Since the thiocyanate concentration is equal to the thiocyanate iron concentration, you can, once you've calculated the thiocyanate concentration, you now know the concentration of the thiocyanate iron for flasks 2 through 5. Follow the instructions on CHEM21 to construct your Excel graph of absorbance versus the concentration of thiocyanate iron. For part 2, use the data from the graph you constructed to calculate the thiocyanate iron of the unknown solution. By the way, when you enter the values for the slope and the R-square values on CHEM21, use those values straight from the Excel graph that you constructed. We can use this mathematical relationship to calculate the concentration of the unknown. Using the typical slope formula, y equals mx plus b, that would then become absorbance equals the slope times the concentration of the thiocyanate iron plus b, which would be the y-intercept. Since the y-intercept was 0 because flask 1 had no thiocyanate and its solution was used as the blank and its absorbance was 0, that relationship can then be simplified as absorbance equals slope times concentration of thiocyanate iron. Isolating the concentration would then be equal to absorbance divided by the slope. C is the concentration of the unknown solution you mixed. Since the concentration of thiocyanate iron is equal to the concentration of thiocyanate. To solve for the thiocyanate concentration of the unknown stock solution, the volume of the stock solution times the molarity of the stock solution is equal to the volume of the mixture times the molarity of the mixture that you prepared in the flask. Isolating the concentration of the stock solution, the molarity of the stock solution is equal to the volume of the mixture that you prepared times the molarity of that solution divided by the volume of the stock solution you obtained originally from the repipette at the side shelf. Express the concentration with 3 significant figures using scientific notation. For part 3, calculate the initial concentrations of the iron 3 and thiocyanate ions upon mixing to 2 significant figures in scientific notation. You may do this by calculating that the molarity of the mixture is equal to the volume of the stock solution you started out with times the molarity of the stock solution divided by the total volume of the mixture in the test tube. Then calculate the equilibrium concentration of thiocyanate iron in each of test tubes 2 through 5 using the formula that concentration is equal to the absorbance divided by the slope that you obtained from the graph. Because your reaction systems are in chemical equilibrium, you have to calculate the equilibrium concentrations for each test tube. The equilibrium concentration of the iron 3 is equal to the iron 3 concentration upon mixing minus the concentration of thiocyanate iron at equilibrium. The equilibrium concentration of thiocyanate is equal to the thiocyanate concentration upon mixing minus the thiocyanate iron concentration at equilibrium. When you do your calculations, express each concentration to 3 significant figures and use scientific notation. And make sure you use those values when you do your equilibrium constant calculations. Use the following equation to calculate the KEQ for each reaction system, which is equal to the thiocyanate iron concentration at equilibrium as calculated using the slope from the graph and the absorbance, divided by the product of the iron 3 concentration at equilibrium and the thiocyanate ion concentration at equilibrium. Express the result of your equilibrium constant calculation as a 3-digit whole number, and then use those to calculate the average equilibrium constant for this experiment.